Just a couple more.
Well, I can introduce myself. I'm Andrew. I'm Derivita Customer Support Lead, and I'm curious about the topic and excited to see one of Sherry's famous presentations.
Oh, God. No pressure there. Thanks, Andrew. All right. Anyone else before we get started? I won't call anybody else's name out, but if you'd like to join in, that's great. I am going to ask that everybody kind of have your camera on for this because it is about discourse. And of course, it's hard to have discourse with a black screen. And normally we like to do this in person because it is a lot of talking, a lot of working together and a collaboration. So we're going to mimic that in this Zoom environment to the best of our abilities. So we're going to jump right in and get ourselves started as much as we can. But I do want to thank Derivita for having me kind of talk to you about this, that this, like Charles said, he's passionate about it, but this is one of the topics that I feel is so necessary in any classroom. I don't care what classroom it is. Discourse is very important regardless of the content, but most especially in mathematics, where we tend to not have a lot of discourse because kids are shy about it or they feel they're not good in mathematics. So I want to thank Derivita, first of all, for even acknowledging that this is a topic of concern and something that we need as teachers to be better at, to help our students be better at. And it starts with the CEO and co-founder of Derivita, Devlin Daly, who through his planning and dreaming up of Derivita, really believes in the technology being a support for teachers in the classroom. And through his imagination, just knowing what to do to help support teachers day in and day out, and using this platform as a way to help us attack things like discourse to make us stronger as teachers in the classroom is really what it's all about. So thanks to Derivita for even acknowledging that discourse is a topic that we really need to focus on. So our agenda today, we're just going to really kind of jump right in, going to discuss a few of our norms just to make everybody comfortable. We're going to talk about talking, and then we're going to jump into the business of it all. So by the end of the session, we're hoping that you're going to understand a bit more about what math discourse really is and the importance of engaging students with it. And also taking away from here a couple of strategies that you will be able to use with your students. And that's the important part. We want you to be able to walk out of here knowing I can go tomorrow and use this with my students and be successful. So are you ready? So we gotta check out the crowd. How you feeling today? So if you have your phone, I want you to get your phone out. If you don't have your phone, but you have your computer handy, which we know you do, I will put this in our chat. But if you have your phone out, go ahead and snap a picture of this QR code. And I want you to put the number of the lot. I guess it's an alpaca. I've been corrected. I stand corrected because Charles is very fond of his alpacas. The alpaca, how are you feeling today? So if you have your phone, snap a picture of the QR code. And if you would like the URL, I'll put that in the chat for you. Maybe, if you're lucky. You have to feel super lucky today. So how are you feeling today? Go ahead and submit that. Oh, look. Wow, we've got some great people feeling today. A lot of 6s and a 7. Everybody chooses the 6. It's something about the hair, isn't it? What is it about that hair that makes you feel that way? The 7, I have to know. Somebody sticking out as the 7. Who chose the 7? I just have to know who the 7 is today.
Oh, Sherry, you know it's me.
Oh, Bonnie, why the 7 today?
Well, I don't know, looks so happy.
He looks so happy. I'm more of I think I'm the 8 today, right? The 8 today, unless I'm going to be a little windblown. Who knows? It's getting a little dark and crazy here. So we could be a little different than that later on. Maybe. We'll see. I might be flying by you later on, who knows? Right? And of course, you hit the wrong things when you don't want to, right? That's what you do. So a little bit about how we're feeling. So if you're feeling pretty good, that's great. What I wanted to do is a quick thing with Derivita. So what you got to see was a bit about SpotCheck. You see how fast I was able to send that out to you, either through you use the URL or you used your phone to actually submit the answer. So just using the platform for a quick spot check on how are you feeling today. It could have been a math question that I asked, but today I just wanted to get a quick, see how you're doing. I mean, nobody was feeling like a number 4, which was great because we've all had those number 4 days. I'm just telling you. So our norms today, active listening, which you obviously are, have that growth mindset. Sometimes these sessions can make people feel a little uncomfortable because it's stepping out of your comfort zone. Active participation, and we want to respect everyone's voices because they all matter. So to start us off, I want you to think for a second. And because we're a small group, we're going to actually just unmute and talk and have this conversation as if we were just sitting around a table. So we want to think about what is mathematical discourse. So think for just a second in your mind, if you had to talk to someone about what mathematical discourse is, what would you say it is? And then feel free to unmute when you're ready.
I look at this, it's me, Jan. I look at this picture and I look at this instructor, hoping that this instructor is encouraging the students to have some conversation about mathematics and what they feel they're doing mathematically and explain what they're doing mathematically with their modeling. It looks, I'm not really sure what they're doing with their experiments, their exploration. So I think of mathematical discourse as getting students to just kind of talk about their math and what they're doing.
All right, getting students to talk about their math and what they're doing. Anyone else like to add on to that?
I would. I think one of the things that I think about as a teacher, and commonly what I did is I always thought about discourse as getting my students to talk to me. But I think what I like about this picture and what Jan was talking about is not just getting the students to talk to me and me talking to my students, but getting students to talk to each other. So now we're all engaged in a conversation around math, and I'm more of a facilitator to that conversation than this being a one-on-one or a direct conversation back and forth with my students.
Okay, interesting. So building off what Jan said, it's not just about the conversation between the teacher and the student, but about the conversation that students are having with each other around the mathematics itself.
Absolutely.
Okay, great. Anyone else?
I think also within those conversations, you want to see evidence that there's actually been some deep level thinking that students are processing, not just their thinking, but they're processing their classmates' thinking, and they're thinking about the mathematics. How did their classmates make meaning of the mathematics, make meaning of these manipulatives that they have? So that in that conversation, it's not just a conversation about the mathematics, but it's a conversation about the problem solving techniques. It's a conversation about how they went from, these visual representations to these algebraic representations. And so making sure that it's rich dialogue that's occurring in the classroom or occurring in these within the discussions.
Oh, perfect. Thank you. I think did you write the definition for math discourse?
No.
I believe you must have. That was perfect because in thinking about that, you reached into several areas, thinking about their thinking, really digging into those processes. How are they moving from concrete to abstract? So getting in there and really analyzing how are they thinking about the mathematics and how are we able to gather evidence of that thinking? So you hit several of those areas in what you said. That was perfect. Thank you for sharing. Other people, anybody else? So you can tell we've had several great inputs around this definition of math discourse. So if we really take a look at it, you can see what NCTM says about what math discourse actually is. Is it what we said it was? Basically, it's everything that we said it was, right? And I believe constructing viable arguments, that's really kind of getting in there, having kids talk about it with each other, really analyzing each other's work. What processes did you use? Critiquing each other's reasoning. That's huge. If we can critique each other's reasoning, then we know the mathematics. So it's getting at those levels, comparing and contrasting. All of those are higher level thought processes. So if you really dissect what this definition of math discourse is, that's where we see those math practices come from. So you can see how they're all intertwined. So when we're talking about math discourse, it's not just about getting kids to talk more. It's not about just talking. It's about what they are actually really talking about and how we as teachers have to really get in there and question correctly to pull that level of discourse from them. So if we expect them to talk about the mathematics, we have to ask the right questions to pull the right vocabulary from them. So that's what we have to really get into. So things to keep in mind as we engage with our mathematics in the future is how are we going to choose the tasks that we're going to be putting in front of students that are going to truly engage them and challenge all of them to want to engage in the thinking? How are we going to ensure that they're going to actively listen to each other? How are they going to learn to agree or to disagree or to even question each other? How are we going to decide in the moment whether we're going to pursue a student's mathematical idea? Or how do we know when to really provide more information or to let students productively struggle with their ideas? How do you know when to help clarify or justify? And how do we end up helping students understand how to have these conversations? How do we lead them from having them between student and teacher to having it between students and students, thus giving them more of the ownership in the classroom? So as we proceed through these activities, I want you to keep those things in mind from a classroom perspective as a teacher. How are we going to make these things or adjustments in our own classroom? So nothing happens by magic. Nothing is magical in a classroom. It appears to be magical. We've all been in those classrooms when you see things happen and you're like, wow, that teacher has it going on. It's like magic. The kids are all doing these magnificent things. And it's like this, it's otherworldly. They're all doing what they're supposed to be doing. They're all doing different things. They're all engaged. But it didn't come without a lot of practice and a lot of structure. That happens behind the scenes. Those are things that we don't see. That's when they have already up front worked out these structures, put in their parameters, their expectations are in place. So it's not magic. These are things that the teacher has already set forth. These are our expectations. Here's how we're going to do these activities. Here is how we're going to progress through these tasks. This is what it's going to look like and feel like and sound like from the student perspective every time we achieve this. So make no mind about it. It's not magic. It's not going to be perfect the first time you ever try something, because you learn from that first time all of the things that need to be in place the next time you try it. And you learn from the second time all the things that you need to do differently for the third time. And by the time you get to the fifth time, you might have a great structure in place for how these things should occur and how your students will behave during these different tasks. So structures are important. So one of the things that I like to kick off with, because it's one of the things that kids love to engage with, and it's really easy to implement. And teachers often think, oh, well, it's just kind of easy and it's just kind of blah. And this, we throw it out there and we're done. Yes, if you just throw it out there and you're done with it, then you didn't really use the task the way it was intended. So one of my favorite tasks to start with a group of students is which one doesn't belong. So I'm going to give you one to think about. And for this first one, I'm just going to ask you to throw in the chat the one that you think does not belong. But in your heart, in your mind, I want you to have a reason to justify why you're throwing that letter in the chat. Are you ready? So when you're ready, just put in the chat which letter do you think should be kicked out? But in your mind, have your justification ready. Interesting. Okay, so we had almost even Stevens, some C's and some D's. Okay, so I'm going to ask someone who chose C if you would please unmute and share why you feel like C should be the one who's kicked out.
I'll speak up.
Okie
I
dokie,
chose
Jan.
I chose C because it was a Greek letter instead of numerical value.
Okay, anybody else who chose C for the same reason?
I chose C for the same reason.
Okay, did anybody choose C for a different reason? I might have chosen C because it was a symbol instead of numbers, right? I might not have come out with Greek letter,
Yeah.
but I might have,
that's what I was
I might have
thinking.
said it was a symbol and it wasn't numbers, but right? So, all right, so
That's
C.
what I thought, but I still chose D, like an idiot. It's probably wrong. Oh my God.
Oh, Catherine, you chose D?
Well, I was gonna choose C for the same
Okay.
reason, like, it's a symbol. Then I overthought it. My master's degree is in literature, so math is already, not my best thing. And I thought, no, it's gotta be D with that line over the 1-4. So
Okay,
this is interesting.
so wait a minute. So you chose D because of the line over the 1-4? Okay,
Yeah.
no worries. All right, so Catherine chose D because of the line. It had a line over the 1-4, and she noticed that none of the others had a line over any of the digits, right?
Yeah, I didn't know what that was for. So I didn't know.
It's for a repeating number, so now you know, but that's cool,
Thank
right?
you.
Okay, but did anybody else choose D for the same reason that Catherine did, because it had the repeating symbol and none of the others did?
And I chose it because of the repeating, because pi, if you were to repeat that, that's not technically what it is. I know A isn't either, but the repeating 1-4-1-4-1-4 doesn't, I don't know, make sense to me, I guess, in the situation.
All you math brains. Charles, why did you change to B? Is it because it's a fraction?
Yes.
It's still a 7, like into 20. It's still the same sum though, right? 3.1.
Well, on reflection, I am changing my answer because B is the only one that is represented as a fraction.
Oh, okay. So Charles, but what did you have before? You had C before, didn't you?
I had C before because it was the only one that was a symbol or a Greek letter,
Okay.
not being represented numerically. But now I'm changing my preference here to B because it's represented as a fraction.
Okay, so Charles is changing his to B because it's represented as a fraction and these other guys are not. All right. Anybody want to agree to disagree with Charles?
You're going to tell us though, right? Because otherwise you're going to have to rock me to sleep tonight.
Okay,
Tell us.
right. Well, let me ask this. Let me just ask it a different way. Charles found a way to kick out B. He said it was the only fraction, so he could kick out B because none of the others were. Would you agree with him? Is his reasoning right? Yeah, it's the only fraction in the picture, so he could kick it out. C was the only symbol or non-numeric number or symbol in the picture, we could kick it out. We can justify it. We could justify D because it was the only repeater. It had that repeating symbol on top. We can justify kicking it out because it was the only one that contained that. So could we justify kicking A out?
Well, I have something based on what Charles was saying. The others, if you were to write them out in decimal notation, you have to keep going forever. 22/7 doesn't end, pi doesn't end, and 3.14 doesn't end. But A is the only one where you could actually write out all the digits if you were to do decimal.
Okay, so A is a terminating decimal. So you're right, it terminates right there. B is a repeating decimal. C is non-terminating, non-repeating, and D is repeating. So we could kick A out because it is a terminator and none of the others are. So who's right here? Because Catherine's got to be able to sleep
That's
tonight.
exactly right.
That's exactly right. So we've
Good
got to
job,
make
sleep.
Catherine be able to go to sleep tonight. So who's right in this picture?
Oh, I love you, Janet.
We're all
So
right.
we're all right. Okay. That's the beautiful part of which one doesn't belong. There is no wrong answer. So do you feel better now, Catherine?
Feel a little better, thank you.
Okay, so the beautiful part of which one doesn't belong is there's no wrong answer. There is an entry point no matter who's in the room. Like Catherine said, she goes, my major was literature. I am not a math person. So I chose D because it's the only thing that had the little line thingy over it. And that's okay. That's her entry point. And we can honor that. That was just as reasonable as Charles saying, I'm kicking B out because it's the only fraction. Does that make sense? Right? So everybody has an entry point. That's the beautiful part about which one doesn't belong. The point here being, if you start your class with an engagement strategy like this, everybody has a point of entry. Everybody has a reason for kicking one of these out. It doesn't have to be a glamorous reason. All it has to be is justifiable, a reasonable justification. So even my non-math person has a way into mathematics here and can feel successful in the math. So we're going to help Catherine feel even more successful in just a second. So that is the part about which one doesn't belong. Engages all, entry point for every student, no matter how high or how low performing they are. And they have to be able to explain their reasoning. Now, I'm going to step out for just a second. What did I do? What were my teacher moves during the activity? Because it's not enough for you to just be a part of it. What did I do during this activity?
Well, one of the things you did, Sherry, that I really liked was you reframed some of the responses using more mathematically precise language. So even though, like Catherine, my background is more literary, I learned some mathematical language, and you made it simple enough that I could take that on, like when you talked about a terminating decimal, for example. That's not language I had in my bank of vocabulary, but I do now. So I really liked the way that you did that because it was super helpful. And I think students would really find that beneficial.
Okay, all right, so the way I reframed some of the answers that students were supplying, what else did I do?
Well, I liked you asked a lot of questions. Why did you choose that? And then you had follow-up questions to those responses, but then you also invited the group to contribute to that conversation about why. And is that, what do you guys think about that? And is that right or is that wrong? And so everybody had a chance to kind of comment and be part of this for each response.
What I really noticed was you asked who else chose C or who else chose D. Did you choose it for the same reason or did you choose it for a different reason? And that brings ownership, to the students for, oh yeah, I chose C as well. I chose it for the same reason, or this is why I did. So that was getting kind of that student to student interaction and communication going while bringing ownership to the reasoning behind why they chose something.
Okay,
And
perfect.
also feeling like those students that all pick the same, there's always strength in numbers. Like you feel like, oh, okay, some other people have the same reasoning that I did. So I'm not a complete, ninny, which is really nice to see people picking the same thing.
Right. And that's exactly it. You all felt a part of what we were doing and your voice was heard. And you felt like, oh, it was okay. My reasoning, like Catherine was like, well, I picked it because of the thingy on top, and you felt weird at first, but other people picked it for the same reason. And you were like, oh, okay. All right, then it's okay. I'm okay. What happened though, we saw Catherine all of a sudden, Charles put in the chat, I'm changing mine to B. And what happened? Catherine was like, well, why? Why are you changing? She took over. I stepped back. And that's going to happen. And I let the students own that conversation until I needed to capture it back, right? And pull it back in. And that's what you're going to find. And that's the beautiful part of it, because that's what you have when you see the mathematical discourse take off in your classroom. But ultimately, it's your job as the teacher to ensure that they're using the correct vocabulary, that you're reinforcing it, like Bonnie called out, that vocabulary that you want them to be using, so that they're not going to say the thingy, and notice that I said, well, Catherine, we call that, and, we want to tie it to the correct terminology, but that's basically how we make meaning of this. So remember, it's really easy to throw one of these things out here and say, oh, this is fun, right? But there's a lot of meaning and thought behind why we would choose the which one doesn't belong that we put in front of kids, and how we would want to interact with it. So we're going to try one more for you. And this one's a little different. Okay, so I'm going to send this one out as a spot check. So hang tight for just a second. So this which one doesn't belong is one of my favorites. Why? Because there's not 4 pieces. There are only 3. So you see 3 pieces, and I want you to supply the 4th piece. I want you to determine what piece is missing. That means you can either decide, do I need to create a graph that fits, or do I need to create a graph that should be kicked out? That's up to you. So I'm going to send it out as a spot check. So if you used your phone before, when I send this out, it's going to refresh your phone, so you don't have to worry about it. And if you use the QR code before, it's going to refresh. Same thing with your website. So you should be able to see this now. So you can either sketch using the pencil, or you can click here and upload an image of a graph that you sketch on a piece of paper. And your goal is to sketch a graph that you think should be in this 4th box, which means you've got to figure out whether you want it to be part of it, or whether you want it to be the one that ultimately gets kicked out. Questions?
Carrie, do you mind putting the QR code back up again, please?
Sure.
Thank you.
Okay, so how do I submit my drawing? I don't see my submit anywhere.
Okay, there should be, did you draw it on the sketch using Sketch?
Drew mine and I lost it.
I just lost it.
I'm not sure who was talking.
Catherine lost hers. I drew it and I lost it.
Janice did too.
I'm gonna put what I want in the,
I'm not sure how you lost it.
you know.
Did I have to hit submit
It's just a
anywhere?
mystery.
I'm not sure. Is that your graph?
Mm-mm.
Are
No,
any of these your
Oh, wait.
graph?
No,
Okay.
no.
If you were doing it on your phone, were you using your phone to draw it?
Yes.
You have to scroll over to the right, and then there would be an OK or a cancel button.
Okay.
Yeah, and if you click OK, then it would allow you to submit it.
So now that I've
It's just-
lost it.
You'll have to do it again,
I have
unfortunately.
to do it again.
Yeah, it's
Oh,
just-
wait, there it is. It came back.
Oh, good.
Okay, so if I scroll to the right,
oh, no.
oh, there it is. I got a lot of extra stuff on mine, but we got the idea.
I'm sure we can handle it. So
I got it.
what we're seeing, I see a lot of different, ideas. Okay, so this first one is different. It says, I would add this graph and then eliminate C. So I'm going to go back to the question. So I'm not sure who submitted that first one. Who submitted that first graph?
That
Right
was
here.
mine.
Of course it was, Charles, because you also typed your response. I should have known. Okay. So notice that I'm not going to notice anything. Charles, tell me why you would add your graph and then kick out C. So tell me what to notice about your graph so I can flip back to the question itself.
So, so I added this one because all of the graphs, so A and D, all decrease to 0. So they all have different paths, but they're all stepwise down to 0. And graph C is increasing. And so I added another decreasing to 0, and then eliminated C.
All right. Did anybody else have the same thought process that Charles did, where they said everything else was decreasing, so they created a decreasing and kicked out C?
Yes, that's what I wanted to do.
Okay,
Because
the same thing that you wanted to do? Looks like this one was very similar as well. Not sure whose that one was. What about this parabola one? This one interests me as well.
That's me.
Okay, can you tell me why the parabola and which one you would kick out, or are you kicking yours out?
I would kick mine out because the others had a more steady set of either increase or decrease.
Okay, great. All right, so you created the parabola, so it was a little smile, and you said it was because everything else seemed to have more of a steady increase or
Yeah,
decrease.
more like a linear function.
Okay, more linear, and yours was more curved, correct? Am I saying that right?
You are.
Okay, all right. So think about this type of which one doesn't belong. What makes it different? What makes it different?
I think it adds another level of thought process. It makes the kids really analyze what kind of graphs do you have? What do you see similar or different in what you have? And how can you add or subtract from that thought process of, I think it just adds another layer of analyzing graphs. What do you see in the graph? And do you want to make one that fits? Or do you want to make one that doesn't fit? I mean, it just really adds to their thought process. My thought process was, I see plateaus. So I see a horizontal line here and here. I did not see it here. So you think it adds in a lot more of graph analyzing of the graph and gets kids to look at different topics of what you're analyzing. I didn't even think about approaching 0. So just adds layers.
I would add to what Jan said too. I tend to look at things of how do I make one belong? So I automatically went to how do I create one that looks like the other ones and then eliminate one, where somebody else, where Bonnie said, how are these three things similar and how do I create one that's visual, very, very different from the other three? So that was interesting. I hadn't thought about looking at it that way as an exercise.
Yeah, just to add to that, so for example, what I did, I noticed these three are all quadrant one graphs, quadrant one only. So I did one using the entire rectangular coordinate system with all 4 quadrants. So same thing, it's pulling different parts of graphing out depending on how the students see it. I think kind of tying back to the first one, it goes back to that ownership. I think this one really pulls the students in to gain ownership on what they are submitting and the why behind their submission.
And think about this, there were so many different ways to approach this problem, and all of them are correct, right? There's no wrong way to approach it. All of them are correct, but yet the way that you approached it lets me have insight into the way that you're thinking and the level at which you're thinking. Does that make sense? And so anytime we do this, if we take that square out, and these don't have to be graphs here, it could be any type. I could have put equations here. I could have put just numbers here. I could have put any expressions here. Could have put anything in here, patterns in here. Could have been anything. The minute we remove one, we've upped the rigor of this question because the level of cognitive demand is now much higher. But it's still an entry point for all students, no matter what level they're approaching their math on, they can still enter this problem. So that's the beautiful part of which one doesn't belong and still taking it to that next higher level and getting at the discourse. And the discourse that happens in your classroom is just that nice, just what happens here. It happens just like this in your classroom with the talk that happens between people. And that's what we have to remember. We have to let that conversation flow. So one other thing that we're going to touch on before we close out today is notice and wonder. And this, again, is something that we hear all the time. Oh, we're going to notice and wonder. We're going to notice and wonder. And I have teachers come to me all the time and say, Sherry, it just didn't work. It just didn't work the way that it did when we were with you. And we'll have to sit down and analyze why it didn't work right. And 9 times out of 10, it's because we don't set the expectations for what we are to notice and wonder, or we don't actually pull from our students the way that we need to get at the level that we would like for them to share. So I'm going to pop up something, and in the chat, I want you to type down what you notice. And you can type in one notice, and once everybody else has typed in a notice, you may type in another notice. Does that make sense? So once everybody has shared at least one notice, you may type in another. We're getting some really good notices. Jan says, I noticed 2 lines, one with a positive slope and one with a negative. All right. It's unusual to have time on the vertical axis, Andrew. Agree. How many of you felt the same way, that you thought it was weird that, especially for math people, time is usually on the x-axis? Just saying. And when we throw time on the y-axis, we thrill our science compadres out there. They love it. I noticed that this graph appears to be a graph of an out and back race. Okay, out and back. All right. Like me, I love it. I noticed the lines are not straight. How many of you did? That's the first thing you noticed, that is that the lines weren't straight, right? Ditto. Okay. I noticed that this isn't a typical graph you would see with those units of distance versus time. Okay, perfect. All right. Now we're going to unmute for this part because there are a few of us. What do you wonder about this graph?
I wonder about the not straight lines. It makes me think about, is this graph hand drawn, or is this the actual data? Because that's very interesting, because these are sort of wavy lines across what should be more constant, or what should be more constant slopes.
Okay, can you be more specific, Charles? Why do you feel like it should be more constant slopes?
I don't know.
Okay.
I don't know. It makes me wonder why that is. And the fact that they're not regular, even in the out and the back. So just makes me wonder what this is a graph of.
Okay, I'm not sure what you meant by regular. What do you mean by regular? You said that they're not regular.
So I would expect, I guess looking at this, I would expect that the slopes are constant on the out and the back legs.
Okay.
But they also, so they're not constant, and they're also not the same. So the out leg and the back leg aren't the same either.
Okay.
So it makes me wonder what this is a graph of, because now I'm wondering all kinds of things about, is this a race? Is it something else that's going on? What is this a graph of exactly?
Okay. You have lots of wonders.
I do.
Okay. Does anyone else have a wonder?
Well, I really want to know what it's a graph of, because whatever it is very good at turning around real fast. There's no time to stop and then turn around and come back. It just bounces off of the wall or something.
Okay. All right. And so, Andrew, just to kind of clarify around that, why do you say that it has to like turn around real fast? What gives you that illusion? Why are you thinking that?
Since it's a pointy graph, I think if it were a person running a race, they would need some time to slow down a little bit more. So
Oh, gotcha.
the slope would kind of gradually change rather than suddenly go from positive to negative or negative to positive.
I gotcha. Okay. All right.
Rounded, opposed to just being so pointed, I guess.
Okay. So it looks, what I think you're saying, it looks too instantaneous, maybe, to be real, authentic, to be a person that could have like switched that fast.
Or it's a superior athlete, really.
Yeah, could be.
It could be like in basketball when you run and hit the lines. So you seriously just turn and run back, opposed to like a distance race or something.
Yeah, like those sprints.
Mm-hmm.
Any other wonders?
Now I really wonder, after hearing Mallory and Andrew talk, because now I'm looking at the graph and I go, 200 meters with an instant turnaround. I don't know what this is now, because it's not a bouncing off a wall. Well, I hope it's not bouncing off a wall 200 meters out.
That would hurt.
Yeah, now I'm wanting to calculate velocity, like meters per second here, figure out what's going on.
I wonder if I regraph it with time along the x-axis and distance along the y-axis, if if I could interpret the meaning a little bit better, since that's what I'm used to. So I wonder if it's okay to regraph.
So Jan, if you were to regraph it, would it change the meaning of the data?
It should not if you're interpreting it as change in distance over change in time. Or, you know, it would change the actual value when you're thinking of slope, change in time over change in distance, the numerical value of the slope. But if you interpret it as instead of time over distance to be distance over time, you're still interpreting the data the same way, but the numerical value might be different. So I wonder about that.
Okay.
I kind of wonder, like Jan, even if you looked at like velocity over distance or velocity over time, so wouldn't necessarily change the meaning, Sherry, but I'd be interested to see what that looked like, you know, if I were looking at this a little bit differently.
What if you were a non-math person and you were looking at it from the standpoint of that? Like, I wonder, could it be the graph of two people?
Well, Sherry, I'm not as adept in mathematics. I won't say I'm not a math person because I think I want to be a math person like everyone else. But I definitely, as I was looking at it, I was wondering all along, how is it possible that there are 2 points on the time in seconds when the distance doesn't change? Like, so I was trying to figure out, how did we get 2 lines? Why are there 2 lines and not one?
Okay. And that's a great wonder. So I wanted to step outside of this for just a second and think about this. What if, I wonder if your class started this way with a graph that was very similar to this, and your teacher showed you this graph and asked you to notice and wonder, to pique your interest. Now, do you have an interest in knowing where this lesson might go? Andrew's like, yeah, maybe.
Definitely more than if we just cracked open our books and it says you're going to have to learn about graphs today.
Right. Because I even wonder, is that it for the graph, or is maybe that just a zoomed in portion of a graph and there's maybe something more there that I'm not seeing? Right? I mean, I wonder a lot of other things about this graph. So now, what if my whole lesson, I need to pay attention now to this lesson, because the math that I'm going to learn today is going to help me find my answers to my I wonders about this graph. And the information that we are going to learn is going to help us interpret this graph. So now we are going to know how to read it and understand what we're seeing. We're going to be able to answer our questions around this graph. So notice and wonder is a great way to really engage all students. But I want you to understand, this can go sideways for people. And let's think about that. How can it go sideways? How could this have gone sideways for me today?
I think the most obvious one, Sherry, is if nobody participates, which is what I hear from teachers all the time. It's just non-participation. Whether it's on Zoom, cameras go off, mics go off, or just in class, nobody talks.
Right. It could have been non-participation. It could have stopped with the suggestion that the lines are not straight. It could have been that the graph is a little blurry, right? Non-math things, right? I still have to honor that, but I also need to go into a little bit more detail. I know that, Charles, you ramped it up because you're looking at velocity. Now you're really into it because now you're more engaged, and you're tending to be my high flyer, but other people are coming at it from, they can see that the rates are a little different. One is, a little faster than the other, but, something's not constant. But you said regular, and what did I do? I made you do what? When you said something wasn't regular, it's not regular. What did I do?
Got more specificity and using math language. So less just sort of generic fuzzy language and more specific about what I'm trying to describe, but using mathematical vocabulary.
Right. And I could have re-engaged the person who said the lines aren't quite straight, and I could have elicited more from that as well, correct? Why might, I could have be more specific, about the lines not being straight. The point, I know that I kind of elicited more information from Andrew a little bit, right? About the break, the wall, the point, being, how do you know, right? That, what do you mean by it's just a quick turnaround or whatever? But it's about how we dig in as a teacher to elicit that information from the students. So a notice and wonder can backfire in many ways if the teacher doesn't engage appropriately with the students to really pull from the students what we need for them to notice and wonder about this graph. I would want them to notice that time was on the y-axis because that is vastly different than what we normally see, right? I would want them to notice that the lines weren't straight, right? But I would also want them to notice other things like Andrew going, it looks like, there's a really quick thing there, or, there's two places on that y-axis, in time, two places in time. And Bonnie's like, that doesn't make sense to me. Why? How can there be two places at one time? Not a function, that we're screaming that kind of stuff. So it's what the teacher does to really elicit those responses from students. And so the notice and wonder is beautiful when the teacher engages at the level of questioning that needs to be done to really elicit the responses from students. So good prompts to use. Bonnie was great. How do you know? Why do you think that? How are you defining X? What might this be? Why might this be important? Just really understanding that we have to dig into the student's understanding. And so if we look at this, notice and wonder piques curiosity because it doesn't take much. It took a simple graph to engage conversation, right? But we have to be confident in what we choose. It can't just be something that we throw up there. We've got to be confident in what we've chosen. We have to be wise about it and thoughtful about it, that it's going to elicit the types of responses that we're looking for, and we have to anticipate those. We want it to align with what we're going to be doing that day. It shouldn't be something that's so way out there that it doesn't align with our topic for the day. It also allows for kids to discover multiple strategies and the big picture to solving problems and reflective skills. So notice and wonder is a great way for getting kids engaged into a lesson. And that's often really hard because sometimes we jump right into the guts of a lesson and kids aren't awake yet into the mathematics of it all. So a notice and wonder can get us engaged into the mathematics and wake our heads up, our minds up, so that we're going, oh yeah, we can do this. Oh, I need to learn this because we're going to be able to explain it over here and use it on this problem. So one of the most important things is what Smith and Stein have done with their 5 practices for orchestrating mathematical discussions. And it all starts with that rich task. And that is hugely important. What we have really focused on today is looking at that rich task and then looking at sequencing results. And so sequencing is one of those things where when we were looking at the results that you displayed with your sketches for which one doesn't belong, I chose two to really focus on, the two that I thought that would really shine as far as what we were looking for in the explanations. So when we're talking about Smith and Stein's 5 practices, we want to make sure that we're going through this in our minds when we're looking at student work. The reason is if we choose student work that is not, we choose student work that is way out there, the glamorous result first, guess what I've done to my entire student population? My lower performers have gone, oh my gosh, I could never think that way. I'm already shut down. I can't do that. I can't do that. And so I have to be mindful of presenting my student work in an order that opens everybody's mind. So if I start with a less glamorous way to get at the work, and then I move up the food chain that way, then everybody's going, oh, wow, I didn't think of it like that. Even the high flyers going, oh my gosh, there was a simpler way to do this. I didn't have to think of it like that. And so everybody's learning from everybody else. So if you've never read that book, it's worth the read. So Smith and Stein's 5 practices for orchestrating mathematical discussions should be a hot topic on your book list. And I know we're running out of time, but there are key questions that you should really focus on when you're thinking about selecting and sequencing. And I'm not going to read those to you because I know you can read yourself. So as we close out today, low floor, high ceiling tasks are the way to go in your classroom because they allow for rich mathematical discourse. And at the end of the day, these things matter. If student engagement equals student achievement and math discourse equals heightened student engagement, then math discourse equals increased student achievement. And so that's what it all means. And that's what we're aiming to get to. So every night, every Wednesday at 3:15 to 4:15 Mountain Time, live on demand, you can get these derivative webinars. And guys, there's a topic every Wednesday, so you don't want to miss out on these. So I urge you to hit the website up and see what the next topics are. And please, as always, Derivita has a Derivita educators community. If you have not joined this, you need to. K-12 educators are in this community sharing their ideas around how they're using Derivita in their classrooms. This is for everyone. So I urge you to reach out, engage, and join in. Thank you so much for being a part of this webinar. I can't thank you enough for all of the participants today for sharing your wisdom, and we will see you next time. Thanks so much.